in between. But we're doing all right. Next week is a short week, so we have that to look forward to. Next week is Thanksgiving Monday, so there will be no classes on Monday. And then just 2 short weeks after that. So we're coming to the end of Term 1A, team. And if you are staying on top of your assignments, that's amazing. Thank you. Make sure that you're also submitting them. If you had something else come up, because we know that there are days like that for sure, today is one of them for me, that if you are a little bit behind, you can still keep working on your MAP4C course past the end of term, which is October 31st. But remember, at the end of term, we do a draw. Any assignments that get handed in this term 1A term, your name gets entered into a draw for every lesson you submit and any course that you obtained, any credit that you get. So things to look forward to, things to keep in mind as we progress through our curriculum material. Yesterday we finished lesson 12. We looked at how the media is the primary source of reporting information. We know that we always want to consider the reliability of a source. We looked at examples of statistics in the news, in the media, in science, and we didn't get to as many of those examples, but you know that they're out there, and how we can be more vigilant in looking at the statistics that we are presented with critical thinking. Is it as it appears? We also learned that when you familiarize yourself with statistical language, you can be knowledgeable and be an informed citizen who can make decisions for themselves. We talked a lot about surveys, survey design, how to report results in different formats like scatter plots. We are moving away from all of that today. And lesson 13 looks at imperial and metric measurements and conversions. So today we'll explore the differences in imperial and metric measurements, and we will better understand how to convert measurements within and from one another measurement systems. If you are feeling confident with the survey design questions, how to read, how to know reliability in statistics, then please move on with us as we tackle a new topic looking at lesson 13 today. If you're not feeling confident in the previous lessons, feel free to go back and re-watch some of the content. Play it again slow, stop it if need be so that you can work on support questions. Remember, they are a great way to help you become comfortable with and feel confident in answering the key questions. Test yourself. Try the support question and then flip to the back of the unit. See if you got it right. If you did, awesome. You can try another one or you can move on. And if you didn't get it, see where you went wrong, and definitely I would recommend trying more of the support questions. If you are feeling confident, here we go. Imperial and metric measurements and conversions. Our learning goals for today are that we will be able to understand the imperial and metric measurement system. We will be able to convert measurements within the same measurement system, and you'll be able to demonstrate how to convert measurements to and from both the metric and the imperial systems. I have a few graphics to start us off this morning. The first, there is a 1-gallon jug of maybe milk, and it's dressed like a king. And then we have these 3 little cartons of probably milk. A little carton is 100 milliliters, a tall carton 500 milliliters, and a little baby carton 10 milliliters. And the 1-gallon king jug is saying, "Take me to your liter." Liter. So, you know, we got to make math fun. The next one is sometimes we will use the different systems of measurement to our advantage. Like when you can say, I only weigh 95 kilograms. It's a smaller number. You feel good about yourself. And then you do that conversion and you find out, oh, that's 210 in pounds. Last one for you. There is a picture of two individuals at a yard sale, and there's a sign that says yard sale. But the one individual says, what if I only want to buy a foot? Oh, keywords that we're going to come across today. When we talk about meter, we are talking about length. When we talk about liter, and in Canada we spell it Litre, we are talking about measuring volume. When we say gram, we're speaking of mass or weight. And when we say Celsius, we're talking about measuring temperature. Now, some really important prefixes that we're going to be looking at today. We have kilo, which references thousand, milli, which also represents thousand, centa is 100, and a deci is 10. So these are the prefixes that come before the word. A kilogram, kilometer. A kilo is the prefix, and it's telling us that we're looking at thousand. Same with milli, millimeter, millicent, millipede. We're talking thousand. And then centimeter, centigram, centipede, 100. And deci is 10. Some background for you on the imperial and metric measures. Up until 1970, Canadians used the imperial measurement system. It wasn't until about 1871 that the metric system was first legalized by Prime Minister John A. Macdonald. Now, this comes from a source written by Craig Baird, who wrote an article about the history behind the imperial and metric measurement system. Now, although it was legalized in 1871, it wasn't actually followed or made, not made, it wasn't forced upon really. It wasn't followed, it wasn't common use. It wasn't until April 1st, 1975, that Canada began to make the formal switch. They said, look, we were using the imperial measurement system. Prime Minister John A. Macdonald legalized it in 1871. Maybe we should start to implement it. There's the word that I'm looking for. We should start to implement it, and you know what? As of April 1st, 1975, this is what we're going to do. We're going to make sure that everybody knows that Canada is using the metric system, and we just need to jump on it and do it. So they decided April 1st was a good time to do this. As you can imagine, a lot of people were a little bit skeptical because April 1st is April Fool's Day. When we look back and we think about the history of, there's politics and everything. We talked about this as we looked at survey design and how it's representative and how there's the use and misuse of. And so, much like everything else, this whole process of metric and imperial was completely muddled with political interference. There was public resistance. And slowly between the 70s and 80s, there's this back and forth. So even though in 1871 it was legalized in Canada by Prime Minister John A. Macdonald, The British Imperial system of units, which we're going to talk more about, but it's based on yards, pounds, gallons, it continued to be predominant in most of the systems. When you think back through history in the 1960s, there were advances in technology and expanding worldwide trade. With this, they decided there was a need for an international measurement system. The size of measurements, when you were asking for a gallon, for instance, it differed between what a gallon was, what it held in the United States, as opposed to Canada. Excuse me. So, despite both countries using the imperial system, there still were differences. It wasn't a universal size. So, in 1970, there was the white paper. Canada gradually began to convert from an imperial to a metric system of measurement. So in the years leading up to 1970, a number of Canadian associations representing diverse interests, including consumers, educators, professionals, they lobbied the federal government to switch from the imperial to the metric system, and so this was known as white paper. In January of 1970, the white paper on metric conversion in Canada set out Canadian government policy. It stated that a single coherent measurement system based on metric units should be used for all measurement purposes, including legislation. So then, in line with this policy, the Weights and Measures Act was amended by Parliament in 1971 to recognize the international systems of units, the latest evolution of the metric system for use in Canada. Now, also in 1971, Parliament passed the Consumer Packaging and Labeling Act, requiring that metric units be shown on labels of most consumer products. So you can see they're starting to become a little bit more firm about we need to make this real. We have to start implementing it. A series of metric conversion events exposed the public to simple metric units in everyday life. First was this big announcement on April 1st in 1975. It was a weather forecast that was broadcast, and it spoke of the temperature in degrees Celsius. Then they started talking about rainfall or snowfall in millimeters and centimeters. The next significant change in 1977 was the introduction of road signs showing distances in kilometers and speed limits in kilometers per hour. Because now we're changing road signs, we have to change the car's speedometers. The speedometers and odometers have to be reflective of this, so they began to be built in metric units. But as you can imagine, you're sitting there, you're watching the news, you've always talked about the imperial unit. We've said, the weather is going to be in Fahrenheit. And now on April Fools, you are told the weather in Celsius. A lot of people didn't believe that this was a real change because it had been talked about for so long. So as things started getting more encompassing with the consumer products, with the road signs, with the cars, it started to grow. In January of 1979, so now we're talking 4 years since the big first official this rollout, service stations started pricing and dispensing gasoline and diesel fuel in liters. And they were told that by December of 1980, nobody was to be using imperial units anymore. That was the cutoff. So we're giving you lots of time to become accustomed to it, to get used to it, to learn what the conversions are. And then we are going to only be acknowledging the metric system. Fabrics, home furnishings were required to be advertised and sold only by the meter and or centimeter. They're cracking down on implementing the new unit. Well, yes, we've had given people a chance to get used to it, but it still wasn't their first go-to. If you can think about some of the people who were older by 1980 and they'd been using the Imperial system their whole life, trying to change now isn't first instinct for them. It's not even habit. So there were a lot of people who were upset. There were a lot of people who resisted. A lot of petitions were filed. The biggest or first problem that came was when they had made the switch in the fuel. It fueled the argument of why there needs to be a consistent system. There was an incident known as the Gimli glider incident. In 1983, Air Canada Flight 143 from Montreal to Edmonton had to make an emergency landing near Gimli, Manitoba because it ran out of fuel. They ran out of fuel because they had miscalculated how much was needed in the conversion of the metric amount of fuel needed for the flight, giving the plane only half the fuel it needed. This became the reason why everybody had to switch and get used to, and we can't go back and forth anymore because it's too confusing, so just learn one system. So all of this I got from an article called Metric Conversion that was edited in 2015, but it shows a little bit of the background of why we use the system that we use. For a lot of people who remember using the Imperial system, you might find this next graphic that I have on the board in front of me a little bit entertaining because it gave me a good chuckle. Even though it was legalized and it's implemented, there are some things that still to this day in 2025 we flip-flop on. So the graphic in front of me is a meme of how to measure things like a Canadian. The first question is, what are you measuring? And then it's this hierarchy, this flow chart. So if you're measuring speed, well then we use the metric system. If you're measuring distance, well, let's talk about what distance. Are we talking about your height? If we're talking about your height, then we're going to use the Imperial system. If you're not talking about your height, maybe are we talking about a long distance? If we're talking a really long distance, then yes, we're going to use the metric system. But if it's not a really long distance, well, are we talking about things related to work? If so, we'll use the Imperial system, and if not, we'll use the metric system. How about temperature? If you're measuring temperature, are you talking about when you're cooking? Because if you're cooking, we're going to use Fahrenheit. But if you're not cooking, well then what are we measuring? If we're measuring the pool's temperature, we're still going to use Fahrenheit. If we're not talking about the pool's temperature, if we're talking about what's our high going to be for the day, let's use Celsius. What about mass? If we're measuring mass, are we talking about your weight? If we're talking about your weight, we're going to use pounds. If we're not talking about your weight, well, how heavy is it? Is it very heavy? If it's very heavy, let's use kilograms. If it's not that heavy, let's stick with pounds. And the last one, volume. If we're measuring volume again, is it for cooking? If it's for cooking, yes, okay, we're going to use in cups and teaspoons and tablespoons. If we're not talking about cooking, then we'll use the metric system. So if any of those ring true for you, you'll see how we still flip-flop back and forth between the metric and the Imperial system. Let's focus on our metric system. The metric system measures objects according to its length, weight, volume, or time. The concept of the metric system is introduced with these measurements. Now, the metric system is also based on the decimal system, as it includes numbers in powers of 10. therefore based on units of 10. I have on the board snippets of how we measure, and this is a little bit more accurate than the meme of how to measure like a Canadian. Here, if we're measuring length, our metric units are talking about millimeters, centimeters, meters, and kilometers. So remember our prefixes, that when we're talking kilo, centi, milli, what these prefixes mean. And they're going to come in handy when we're looking at those units of 10 for converting. When we're talking mass or weight, the measurement of, we're using milligrams, centigrams, grams, kilograms, and ton. When we talk measurement of area, we use the language square centimeters, square meters, square kilometers, hectares, which is 10,000 square meters. And then lastly, if we're measuring capacity, we're talking millimeters, centiliters, liters, and kiloliters. When we need to look at conversions, it's important to keep a few of these staples in mind. It's good to know that when we're measuring length, 1 centimeter is equal to 10 millimeters. 1 millimeter is equal to 0.1 centimeters. 1 meter equals 100 centimeters. 1 centimeter equals 0.01 meters. 1 kilometer is 1,000 meters, or 1 meter is 0.001 kilometers. So here's where you can really see that the metric system is based on the decimal system, as it includes numbers in powers of 10. You can see how all we're doing is shifting the decimal to convert between centimeters, millimeters, meters, kilometers. Similarly, you can see, if you're following along on the board, when we are measuring mass and weight and capacity, we're dealing with those units of 10, those base powers, and all we're doing is shifting the decimal place. That 1 ton equals 1,000 kilograms, or 1 kilogram is equal to 0.001 ton. We're just shifting that decimal place. Now, when you need to convert between the systems, it gets a little bit trickier. We know that the metric system, 10 millimeters is equal to 1 centimeter, 100 centimeters is equal to 1 meter, 1,000 meters is equal to 1 kilometer. And that's, again, keeping in mind our prefixes, that kilo is 1,000. You can see how it starts to help us know for conversions. Kilo is, or I can do it this way, 1,000. Now the imperial system has 12 inches equals a foot, 3 feet equals 1 yard, 1,760 yards equals 1 mile. It's not as easily shiftable in the sense that we're not talking about those units of 10. When you want to convert between the two, you can keep in mind that 1 inch, so that's the imperial system, is approximately equal to 25.5 millimeters in the metric system. 1 foot is approximately equal to 30.48 centimeters. 1 yard is approximately equal to 0.9144 meters. And 1 mile is approximately equal to 1.609 kilometers. Now, you're not expected to memorize all of these. It's good to know when you're looking at a mile is not equal to 1 kilometer. So if someone says 1 mile, you're actually talking 1.6 kilometers. It's more in kilometers. these things are good to know. For your exam at the end of the course, remember it is open book, so you will be given these formulas and conversions if and when you need it. A nice way to visualize the conversion in the metric system when we're talking about length is there's this fun, almost like a number line that I got from QMath, and it's telling us that here in the center is our meter. When we're talking length in the metric system, we're basing it off of the meter. Anything that is decicentimilla, those are small units. That's like we're talking less than, they are small. We're getting into the 10/100,000ths, tenths, hundredths, thousandths idea of the smaller. Bigger units are the deca, hecto, and kilo. So decameter, hectometer, kilometer, or kilometer. You can see from the graphic on the board, so we have kilometer or kilometer from the left going to the hectometer, the decameter, and then our meter in the middle. And then farther down the right, our smaller units are decimeter, centimeter, millimeter. And on top, what we have is this times 10 between all of them. It's letting us know that to convert between any or all of them, it's just in those units of 10. So the next example or graphic that I have on the board is this metric system conversion, starting at the meter. Anything above or bigger, for each step up, you are going to divide by 10. When we divide, we are moving the decimal place to the left. Just like when we have 8% and we want to know it as a decimal, we move that decimal to the left because we're dividing by 100. On the other side, when we are looking at smaller units, when we're going from big to small, and maybe I can write this, so you can use this as your study guide, I guess. When you are going from small to large, smaller to bigger, you are dividing. When you divide, you're moving the decimal left. So you can write that in your notes. When you're going from small to large, you're going to divide, and when you divide, you're moving to the left. On the other hand then, when you're going from large to small, you need to multiply. And when you multiply, you are moving the decimal to the right. So again, for an example, if we had 49%, just like we did with our very first lesson when we're talking our formulas, we needed to put in our interest rates. You had to express it as a decimal. When we are going from big to small, we divide, and percentage means of the 100, so we're dividing by 100. You can write that 49 as 49.0. It's a whole number. When we're dividing, we're moving the decimal to the left. Because there are 2 zeros in 100, we move that decimal place 2 spots to the left, which gives us 0.49. So it's not new news. We've done this before, but it's another way to see it, to picture it, to think of it. So let's do a few examples. Say we have 570 millimeters that we need to convert to centimeters. So we're looking here at millimeters. Here's our millimeters. And we want it to be centimeters. So we're moving up one step. For each step, you either multiply or divide by 10. For those that are just listening, the graphic on the board in front of me is kind of like upside down stairs because we're starting with the big units on the top. So kilometer is on the top, and then underneath is the hectometer, then the decameter, then the meter, and our steps are getting smaller. We have the decimeter, the centimeter, and the millimeter. So if we're climbing up our step, we are needing to, when we're going from small to large, we have to divide. So if I have 570, it's like saying 570.0. I need to divide because I'm going from a small unit of millimeters to a larger unit of centimeters. So small to large is dividing, and when I divide, I move the decimal to the left. So I move my decimal one spot to the left, giving me 57.0 centimeters. Let's try another one. Here, I'm saying 3.2 kilometers, and I want to convert it to hectometers. So now I am working from large to small. I'm starting at kilometers, and I need to get to hectometers. When I go from large to small, I have to multiply. So I'm going to end up multiplying. Now I was only going one step from millimeter to centimeter, so I just divided by 10. Here I'm going one step, so I'm going to multiply by 10. So 3.2 kilometers. When I multiply, I move my decimal to the right. So I'm going to move one spot because there's just one zero in 10. So I'm only moving one decimal place. So that gives me 32 hectometers. And you include that zero or you don't. You can just say 32 hectometers. That's okay. What if we need to jump by a few steps? The next example is 9,120 meters, and we want to convert it to kilometers. So meter is my starting point, and I want to convert to kilometers. So the meter is small, and I'm going to a larger unit. When I go small to large, I'm going to have to divide. And then how many am I dividing by? I'm not going one step. I'm going 1, 2, 3 steps. So one step would be to divide by, I'm going to get a different color so that it can stand out. When I am dividing one step, I divide by 10. Another step, I'm dividing by 100. And another step, I'm dividing by 1,000. And we can also, without having to count the steps, we know that kilo is 1,000. So there are two ways to help you remember. You can go through each step, or we just know kilo, that prefix is 1,000. So that means that I am going to divide by 1,000 to get from meter to kilometer. So I have 9,120.0. When I divide, I'm moving the decimal to the left. And this time there are 3 zeros in 1,000. There are 3 steps. I'm going from deca to hecto to kilo. So that's 3 steps, 3 zeros. I have to move the decimal place 3 times. And whenever you're going from small to large, you're dividing, you're moving the decimal to the left. So I'm going to move my decimal place 1, 2, 3 spots. That means that 9,120 meters is equal to 9.12 kilometers. Let's try one more. Here I have 84 centimeters. So I'm at centimeters and I want to get 2 meters. So my new starting point is here at centimeters. and I'm going up 1, 2 to meters. That's where I want to end. I'm going from small to large, so I know I have to divide, and I'm going up 2 steps from centimeter past decimeter to meter. So here I would divide by 10, divide by, sorry, this one's 10 because this one is my unit, and here 100. So I need to divide by 100. So I have 84.0 centimeters. When I divide, I'm moving the decimal place to the left. There are 2 zeros in 100, and I've gone up 2 steps, so I'm moving my decimal place 1, 2 to the left. That means that 84 centimeters is equal to 0.84 meters. So it's just a matter of how many steps are you moving? Do you move to the left or to the right? Are you going up? Are you going down? Are you going larger? Are you going smaller? That'll help you to know if you're going to divide or multiply, and then you'll know how many places to move the decimal. Converting within the metric system is beautiful. Because of the units of 10, the powers of 10, we are able to simply move the decimal places. So if you need to, you can make a little study cheat sheet on this if it helps, and you can see, if there's another graphic, how it all works to convert within. So the next graphic is metric conversion of length, which we were doing. We have the millimeters, centimeters, meters, kilometers. When you're going from small to large, you're dividing. You can see the next, another visual. And then when you're going from large, kilometer down to meter, you're multiplying. When you go from meter down to centimeter, you're multiplying. When you go from centimeter down to millimeter, you're multiplying. So it's another way to see it, to look at it. Maybe this graphic helps you to better visualize those steps, so to speak, and how to know when to multiply, when to divide, and by how many. Let's practice some examples together. Here we have a practice question that tells us to convert each length. We have to go from 365 centimeters, convert it into meters. Well, we are going from small to large. Centimeters are a smaller unit than meters. When we go from small to large, we have to, that means divide. And when we divide, we are moving our decimal place to the left. So that's our cheat sheet. That's what's helping us to remember. So we have 365 centimeters. Meters is 2 steps above. We have centimeters, then decimeter, then we get to meter. So that means that we have to divide by 100. There are 2 zeros in 100, so we're going to move our decimal place 1, 2 to the left, giving us 3.65 meters. And you're going to do that for all of them. We're going to jump for the sake of time. We're going to jump down to part D. So we're still converting the length. This time we're going to skip A. No, we did A. We're going to skip B and C and look at D. D says convert 12.942 kilometers to meters. Kilometers is our big unit of measurement. It's large. So we're going to go from large down to small. when we go from a large unit of measurement to small, we have to multiply. And when we multiply, it means that we are moving our decimal place to the right. So we need to do 12.942 times how many? How many is it from kilometers to meters? If you remember, our meter is sort of that neutral, that base, and kilo means 1,000. So that's our hint that we're going to have to multiply by 1,000. So take our decimal place, and there are 3 zeros in 1,000, or there's those 3 steps. We're going from meter to decameter to hectometer to kilometer or kilometer. So that's 3 steps, 3 zeros. We're moving our decimal place 1, 2, 3 to the right, telling us that 12.942 kilometers is equal to 12,942 meters. And you can include that zero, the decimal zero, or not. That's preference, that's up to you. I thought that would be all the time that we have for today, but you know what? Maybe we can do some of the other ones. Let's do some of the other ones since I already made the stop time after this lesson. Question. All right, let's go back to B. B says 14,311 meters, and we want to convert to kilometers. We have a small unit. We're going from small to large, which means we have to divide, which means we have to move the decimal place to the left. 14,311. And then we can put decimal zero so we can picture it. How many places do we move the decimal to the left by? Meters to kilometers. Remember, meters is kind of our neutral, that's our base. And kilometers, that kilo equals 1,000. So we know that we are going to have to divide by 1,000. And there are 3 zeros in 1,000, so we're moving our decimal place 1, 2, 3 times. That means that 14,311 meters is equal to 14.311 kilometers. The next practice question, C, says 1.9 meters. Convert it to centimeters. What is 1.9 meters in centimeters? Here we have a large unit. Meters is large, going down to centimeters, which is smaller. That means that we are going to have to multiply, which means I am moving my decimal place to the right. 1.9. Now, how many places do I move my decimal? Well, centa, if you remember our prefixes, kilo is 1,000. Centa, C-E-N-T-I, means 100. So we know that we are going to have to multiply by 100. Or you can walk through the steps. You can see that meter then goes down to decimeter, then goes down to centimeter. We're moving those 2 steps. So 10, then 100, and then if we wanted millimeter, it would be 1,000. But we're just going down the 2 steps, so it's 100. That means we have to move our decimal place 2 to the right. Because it's 2 steps, there are 2 zeros in 100. 1.9, you move the decimal place 1, 2 spots. I'm waiting for my ink, there it goes, to catch up to. Because I don't have enough numbers, so to speak, in 1.9. My decimal place is kind of hanging out in space far to the right. That doesn't mean that I can write 19 decimal 0. What we need to do is we need to put this placeholder in here. And a placeholder is our 0. You can't just say, oh, well, I ran out of numbers, so it's just going to be 19. No, don't do that. We need to put a 0 in there as a placeholder. So 1.9 meters is actually equal to 190 centimeters. Make sure you're using those zeros as a placeholder when need be. But at the end, so our example D, where it's 12.942 kilometers converted into meters, it's 12,942 meters. I said you could write it as 12,942.0, but when it's at the end, it's not needed, so you could just write 12,942 meters. It's okay when it's at the end. When it's needed to move the decimal place, you have to put that 0 in as a placeholder because there's a huge difference between 19 centimeters and 190 centimeters. So if you're building a house and you're cutting and you're measuring and you say, well, I didn't have another number, so I'm just going to make it 19, you're going to have a very off build, a very off cut. So be sure to include those zeros as placeholders when you need to. All right, we're going to end our lesson there. We are going to continue with lesson 13 tomorrow. We knew it was going to be a two-part one to get into everything that we need to cover. I hope you have a great rest of your day. I hope you're staying warm. Join us again tomorrow at 10 o'clock so we can continue with lesson 13.